All right, guys, here we go. Last video of the section. To start, I just wanted to follow up with that previous question. I have just plotted those two graphs. I just copied them into Desmos graphing calculator, and this is actually the app I'm using, but you can use it on your desktop too. And then here's the line y equals x. So you see how those do in fact reflect each other? Isn't that really cool? So looking at the blue line and the red line, if I was to reflect them over that green line, they'd land on top of each other. So really beautiful thing that happened there. Okay, let's get back to it. Where were we? We're in the last section here. Last section is just about determining domains and ranges of a function and its inverse. And just one main fact you have to know. The domain of f is the range of its inverse. And the range of f is the domain of their inverse. So they're just opposite of each other. And that's all. So the remaining questions, we're just going to do a little more practice finding the inverse. And then just checking the domain ranges by that one fact I just mentioned. So that's this set right here. 5 more questions to go, and we are out of here, guys. Sorry, this is kind of a long section. A little longer than usual. So number 18 first. Okay, find the inverse first. Is for x bigger than or equal to 0. So that's the domain for f, right? So, okay, let's do this first. First step, where is y? Second step, exchange this. So it's going to be x equal to y squared minus 4. Solve for y, it's going to be x plus 4 equals to y squared. Y is equal to the square root of x plus 4. Okay, now let's check the domains. So look, all I have to do is check for f. All I got to do is check for f. So the domain, because it said x is bigger than or equal to 0, domain was 0 to infinity. And then what's the range then? The range for f, if I plug in 0, I get negative 4, right? And then I get everything above that. So it's going to be negative 4 to infinity. So already, that's going to give me the domain and range for the inverse. So inverse, the domain is negative 4 to infinity. And look, that matches because look, it's got to be bigger than negative 4 or negative 4 for this to make sense, right? Take a square root. And what about the range? It's 0 to infinity. I can get 0 and I can get anything higher than that. So yeah, perfect. Beautiful. That's it. Number 18. 18 done. So hopefully we can finish relatively close to a 75-minute class here. That one is gone. Okay, number 19. Let's see. First step, change with y's. Y is 1 minus x squared. Exchange x and y's. Now solve for y. X minus 1 equals to negative y squared. Divide both sides by negative 1. I got negative x plus 1 is y squared. And then take a square root. So y is equal to the square root of negative x plus 1. Okay, now I'm going to check the domain for f. And it's given to me. Yeah, x got to be bigger than or equal to 0. So 0 to infinity. And then if I put in 0, that's 1 minus 0, right? And if I put in something bigger, it's going to be smaller. So it looks like the largest I could be is a 1. Sorry, largest I could be is a 1. And then I can get anything that's smaller than that, negative infinity. And I can confirm that by just graphing it real quick. So positive 1, negative x squared, opens downwards. But it's only for x positive, sorry. So only this side of that graph, yeah? So I get from 1 and below. That's the range. This is the domain and range for the original f. So that means that for f inverse, the domain and range should be switched. Should be negative infinity to 1 is possible values. That makes sense here because this is a negative. And then the range is from 0 to infinity. That's matching this part, right? Yeah, so if I take a square root of something, I can get 0, and I can get anything bigger, but I can't get anything else. So that's it. Number 19 down. All right. That's not so bad, yeah? This is not so bad. I think this is way easier than the previous section. You can expect a question where you have to find the inverse by using this technique, yeah, switching the y's and x's and all that. So y is equal to negative x cubed, first thing. Oop, I have extra cube there. Negative x cubed. Second step, swap x and y, and then solve for y. So first thing, divide by that -1. So I get negative x equal to y cubed. Now I take a cube root. Y is the cube root of negative x. Okay, looking at this, there's no restrictions on the domain here, right? So if I look at f of x, its domain is everything. Everything. What about the range? Well, I could get everything again. Yeah, because x cubed was like this. Negative x cubed would be like this instead. So yeah, I get everything. Negative infinity to positive infinity. Okay, looking at my f inverse, does that make sense? Domain should be this range, so also negative infinity to positive infinity. And that makes sense because I could take a cube root of anything. And then what about the range? Well, yeah, I can get anything as well because I can input something really big and get something really big, or something really negative, get something really negative. So yeah, domain and ranges, negative infinity to positive infinity all around. That's number 20. 20 is done. That was an easy one. Okay, 21 and 22 now. I think I mentioned this before, guys, but you know, some people, if you're having issues with homework or you're stuck, just you can always request. I've been making like individual videos for people who ask questions. So if that's you, you get stuck on one, don't hesitate to ask. Okay, step 1, replace with y's. Step 2, exchange y's and x's. This time I want to get rid of the square root first. So I square both sides. I got x squared is equal to y minus 6. And then plus 6. X squared plus 6 is equal to y. There we go. Okay, now let's see. This is an interesting one. So f of x, if I look at the domain, this inside has to be positive, right? So domain, the x has to be bigger than 6 to make that positive. 6 or bigger. And then the range, well, if I take a square root, I can only get positive values. So it's going to be 0 to infinity. That means when I take a look at the inverse function, its domain should be 0 to infinity. It has to be restricted to that as an inverse function. Even though if I look at it at face value, so this is the inverse function, right? Oh, I'm sorry, guys. You know, I've been forgetting to actually write the final answer. The actual inverse function is f inverse of x equals to x squared plus 6. But you can just think of that as the inverse function as well. But if I was to formalize the notation here, this is the inverse function, yeah? Okay, so, but restricted here, where for x in this domain from 0 to infinity. So I only want this inverse function where x is from 0 to infinity. And then what about the range? The range is from 6 to infinity. Because look, if I plug in 0 here, the smallest value I'm going to get is 6. So that makes total sense, yeah? These guys are all just reverse each other again. And that was number 21. Leaving us with just one more question to do for the whole section. We're almost there, guys. We're almost there. Don't lose heart. Don't be afraid. We're almost there. Almost done. Let's just celebrate with a new color. Let's work with this green color. Okay, this is 22. First step, y equals -1/x. Second step, exchange x and y. Okay, and then solve for y. Oh, okay, this is an interesting one. How do I solve for y? First, because y is in the bottom, I'm going to multiply on both sides. So I get xy is equal to -1. And now, get y by itself divided by x. So y is equal to -1/x. And, oh, interesting thing happens. Look, it's its own inverse in this case. So f inverse of x is also -1/x. All right, what's the domain and range? Let's use new colors. Start with f of x. Domain. Okay, well, domain can be anything except for 0, right? So if I just write that as an interval, -infinity up to 0, and from 0 on to positive infinity. What about the range? Well, there's no way I get 0, but everything else I can get. So it's going to be same thing, negative infinity to 0 and 0 to infinity. That means for f inverse of x, it's going to have the same domain and range because it's all the same, right? Negative infinity to positive infinity, and the range is negative infinity to positive infinity. And if you think about it, it's got to be that, right? Because they're the same. Look, they're the same exact function. I'm sorry, I circled the wrong things. The inverse function and the origin are the same. So, of course, the domains and ranges have to all be the same thing. So, yeah, makes sense. That's it, guys. Done. Thanks for sticking with me. Hope you have a great day.